Good morning, good afternoon, good evening. This presentation will cover the first lesson of STM 1-on-1 Pre-Calculus Conic sections. So to start, let us have a review on what are conic sections. These are figures formed by the intersection of a plane and a right circular cone. A conic section may be a circle, an ellipse, a parabola, or a hyperbola, depending on the inclination of the plane. Sometimes we can have a double right circular cone, as can be seen in this image right here. So depending on the angle of inclination or how much the plane is tilted, we can get different kinds of conic sections. So for the first type, we have circles. So circles are formed when the plane is parallel to the base of the cone. Or, in other words, it is formed when the plane is perpendicular to the axis of symmetry. In the module, the second definition is being used, so we will stick with that. So again, it is formed when the plane is perpendicular to the axis of symmetry. Next is parabola. A parabola is the curve formed by the intersection of a plane and a cone when the plane is at the same slant as the side of the cone. It is formed when the plane is parallel to the side of the cone. We could also notice that this is the graph of quadratic functions. We could observe in this image right here that the plane is parallel to the side of the cone. Okay, next we have hyperbola. A hyperbola is formed by the intersection of a plane parallel to the axis of symmetry. The plane cuts both halves of the cone. So we have a double right circular cone that is being cut by a plane parallel to the axis of symmetry. Okay, so let's move on to ellipse. The ellipse is produced when the plane that intersects the cone is oblique or slanting. So we could see that the plane cuts the cone at a certain angle that is not really parallel to the side, but and not it is also not parallel to the base. So it's kind of a in the middle, in between of those. So it's basically an oblong. Okay, so next we move on to determining the conic sections. So we have the general equation of conics. Ax squared plus bxy plus cy squared plus dx plus ey plus f equals to 0. And we also have the cases or the guides here. This is the only thing that we have to remember for this lesson. So based from the general equation of conics, if A is equal to C, then it is a circle. If A is not equal to C, but they both have the same sign, then the equation is an ellipse. If A is not equal to C and they don't have the same sign or they have different signs, then the equation is a hyperbola. Lastly, if either A is equal to 0 or C is equal to 0, then the equation is a parabola. We have our example here. The first equation x squared plus 3x minus 8y minus 5 equals to 0. This is a parabola because we cannot find the y squared term. We cannot find the c. So that means letter C is 0. So again, if either A is equal to 0 or C is equal to 0, then the equation is a parabola. Next, we move on to the second one. 2x squared minus 3y squared plus 3x minus 5y minus 2 equals to 0. This is a hyperbola because not only our A and C coefficients, A and C are different, they also have different signs. So for our A, it is positive, but for our C, it is negative. Next equation, 6x squared plus y squared plus 3x minus 8y minus 5 is equal to 0. This is an ellipse because though our A and C coefficients are different, they still have the same sign. So going back to our guide, oh wait, okay, going back to our guide, if A and C are not equal but they have the same sign, then the equation is an ellipse. So our A coefficient is 6, while our C coefficient is 1. That's why it is an ellipse. Next, 7x squared plus 7y squared plus 3x minus 8y minus 5 equals to 0. This is a circle because our A coefficient and our C coefficient are equal. They are both 7, positive 7 to be exact. That's why this equation is a circle. Next, if we plot them into a graphing calculator, or if we graph them manually, we can get these graphs. Okay, we move on to the guided practices. So again, this guide is the only thing we have to remember for this lesson. It's pretty simple. Okay, so for our first guided practice, we have 3x squared plus 5y squared minus 6x plus 2y minus 9 equals to 0. So from here, we look at the A coefficients and C coefficients. A coefficients are the numbers beside the x squared. Remember, these are the numbers before x squared, while the C coefficients are the numbers that are usually they're always beside y squareds, the term y squared. So our A coefficient for this equation would be 3, while our C coefficient will be 5. So 3 and 5 are different. They are different, of course, but they have the same sign. They're both positive. So we go back to the guides or the cases. If A is not equal to C, but they have the same sign, then the equation is an ellipse. So therefore, this equation is an ellipse. Next, So 3y squared minus 4y equals to 2x squared plus 9x minus 3. So basically, we have to first look at, again, the a and c coefficients. But here in the equation, it's not in the general form. It's not in the general form. So we have to transpose the two. Well, we can either transpose the right side of the equation to the left side or the left side to the right side. But for this, it's easier to just transpose the left side of the equation to the right side. So again, if we transpose, the sign of the terms change. So for example here, 3y squared, positive 3y squared, if we transpose this term to the right side, it will be negative 3y squared or minus 3y squared. So for negative 4y, if you transpose this to the other side, it will be positive 4y or plus 4y. So positive 2x or positive 2 and negative 3. Again, it became negative because we moved it or we transposed it to the other side. So again, positive 2 and negative 3. They are both different numbers and they have different signs. Therefore, the equation is a hyperbola. Okay, so we move on to the next equation. 6x squared plus 12x minus y plus 15 equals to 0. So from here, we could already determine immediately the conic section because the y squared term is missing. When the y squared term is missing, that is because the c coefficient or the number that comes before it is 0. So if c is 0 and we still have a, which is 6, then that means the equation is a parabola. Because if either is equal to 0 or c is equal to 0, the equation is a parabola. Next, we have 4x squared plus 4y squared minus 8x minus 8y equals to 0. So again, we look at the a and c coefficients. So we have 4x squared and 4y squared. So we have positive 4 for both of the x squared and y squared terms. So if a is equal to c, then the equation is a circle. So therefore, this equation is a circle. Next, 2x squared minus 2y squared plus 3x minus 2y minus 43 equals to 0. So maybe at first we think that it might be a circle because we could see that two, the two twos, or the x squared and y squared both have 2. But actually, this is a hyperbola. Why? Because for the x squared term, its coefficient is positive 2, while the y squared term, the coefficient for the y squared term is negative 2, which is completely different from positive 2. So if A is not equal to C and they both have different signs, then the equation is a hyperbola. Next, 4y squared plus 3x minus 6y minus 12 equals to 0. So from here, we notice that the x squared term is missing. So again, if that's the case, the equation is a parabola. Uh, okay, so that's clear. We have to let us move on. Here, 27 y squared minus 108 y is equal to negative 9x squared plus 6x minus 82. So earlier we had a similar problem or similar equation wherein we moved the left terms to the right terms. But here, since we have a negative coefficient for our x squared term, it is easier to move the right group of terms to the left side. So if we do that, negative 9x squared becomes positive 9x squared. Positive 6x becomes negative 6x. Negative 82 or minus 82 becomes positive 82. So we only have to focus on the a, which is the x squared. So again, negative 9 becomes positive 9 if we move it to the left side. So we have positive 9 and positive 27 as our a and c coefficients. So we go back to the cases. If a is not equal to c, but they have the same sign, then the equation is an ellipse. Okay, so next, 8x squared plus 3y squared minus 12x plus 6y plus 18 is equal to 0. So we look at the a and c coefficients, which are 8 and 3. 8 and 3. And then we go back to the guide and we notice that it is an ellipse. Why? Because the a and c coefficients are not the same, but they have the same sign. It's that easy. Last, x squared plus y squared is equal to 4. This equation is a circle. Why? Because our a and c are equal. So for our x squared term, we have 1. For our y squared term, we have also 1, positive 1 to be exact. And that's it. It's pretty basic. You can get it. All you have to do is just remember the cases. Like you really have to familiarize them. And of course, you have to be mindful of the equation. You have to know how to transpose properly, and you have to know how to determine which are the a and c coefficients. That's it. Thank you for listening. Good morning, good afternoon, good evening. This presentation will cover the lesson 2 of STM 111 Pre-Calculus Circles. We begin by defining what is a circle. A circle is the set of all points pxy in a plane whose distance from a fixed point called the center C, hk, is a constant r called the radius. Thus, all the points on the circle are of equal distance r from the center. Next, things to remember. When dealing with circles, we have to know, or we have to remember, the standard forms of a circle. So the first equation here is the standard form of a circle when the center is not on the origin. So that means the coordinates for the center is not 0, 0. While the second equation right here is when the center is at the origin. Next, the general form of a circle. We have to know um, the coefficients of our equation, which is A, which is C, D, E, or F. If we remember or we know this form, general form of a circle, we can easily get our H, our K, and our R by following these formulas. We also have to know how to complete the square. We simply have to follow this. b, b over 2 squared. Next, we also have to know the midpoint formula, which is x sub 1 plus x sub 2 over 2 and y sub 1 plus y sub 2 over 2. So let's begin with our guided practices. Find the center and radius of x squared plus y squared equals 9. So from there, we could already determine um, our answers because it's the equation is pretty basic. So first, we have to transform 9 into its squared form, which is 3 squared, because 3 squared is equal to 9. So from here, since there are no other numbers beside x and beside y, we can assume that the center is at 0, 0, and our radius is 3 because we already transformed the 9 into its squared form. So it's pretty easy to determine. Next, find the center and radius of x plus 4 squared plus y plus 2 squared equals to 25. So let's write this as our guide. Now, we have to expand um, x plus 4 and y plus 2. So since x plus 4 can be written as x minus negative 4 and y plus 2 can be written as y minus 2. Hmm. We do this so that we can easily get or determine our h and k, and then we will transform 25 into its squared form, which is 5 squared. So from here, we can just get our h, which is -4, and our k, which is -2, to form our center, to come up with our center. And just simply get our radius, which is 5. Next, x squared plus y squared plus 8y equals to 33. So we notice that it's not in the standard form, rather it is in the general form. So that means we can use the formulas given earlier, which are which is first to find the h. We follow the formula -d over 2, and k, for the k, we follow -e over 2, and for our r, we follow the square root of h squared plus k squared minus f. So as we could notice that the d is missing. So that can only mean that d is equal to 0. That is why we put 0 here. And 0 over 2 is always 0. That means our h is equal to 0. For our k, our e for this equation is 8. So we simply replace e with 8. So -8 over 2 is equal to -4. Now that we have the values for h and k, we can get our r. So we simply replace the values for h, k, and f. By the way, our f here is -33, not 33, because first we have to transpose 33 to the other side, and when we transpose a number, we change its sign. So from positive, it becomes negative. So if we put this in our calculator, or if you can do it manually, we can get 7. Therefore, our center is at 0, -4, and our radius is 7. Next, convert x squared minus 4x plus y squared minus 4y minus 8 equals to 0 to standard equation. So note, we have to use the b squared over b over 2 squared to complete the square. So first, we have to separate or visualize the separation between the x's and the y. And also, we have to transpose or transfer -8 to the other side. So it becomes +8. Now, we have to complete the square. So first we have to do is to determine which is the b in our equation or in our terms. So for the x's, the b here is -4. So -4 over 2 is -2, and then we square that. -2 squared is 4. So we get 4. It is also the same with our y's. -4 over 2 is -2. -2 squared is 4. So whatever numbers we add on this side of the equation, we also have to add them on the right side. So it becomes 8 plus 4 plus 4. So after that, we have to simplify. 8 plus 4 plus 4 is 16. And now we have to simplify our terms. So from x squared minus 4x plus 4, it becomes x minus 2 squared. And our y squared minus 4y plus 4 becomes y minus 2 squared. A tip here is whatever number comes up when you divide 2 to b. So when you uh, do the b over 2 part of the completing the square, you put the answer here. So for example, negative 4 over 2 is negative 2. That's why we put negative 2 here. And that's our answer. Next, convert 9x squared plus 9y squared minus 6x minus 24y equals to 19 to standard equation. We could notice that um, our x squared term and our y squared term both have 9 as their coefficients. To make our equation simpler, we simply have to factor out 9 from the equation. We can do that by dividing 9 from each term of our equation. So if we do that, we get this. X squared plus y squared minus 2 over 3x plus 8 over 3y equals to 19 over 9. Next, what we have to do is to regroup the terms. So we group our x's, and then we group our y's. So the next thing to do here is to complete the squares. Again, negative b over 2 squared. So for our x's here, it's negative 2 over 3 divided by 2. And then you square that, you get 1 over 9. For our y's, 8 over 3 divided by 2 squared. If we do that, we get 16 over 9. So again, whatever numbers we add to this side of the equation, we also add to the other side. Then we simplify the equation. 19 over 9 plus 1 over 9 plus 16 over 9, we get 4. And then if we simplify our x's and y's, we get x minus 1 over 3 squared plus y plus 4 over 3 squared. Again, whatever answer comes when you do the b over 2 part of the completing the square, that's what you put here in the parentheses. So negative 2 over 3 divided by 2 is equal to negative 1 over 3. 8 over 3 divided by 2, we get 4 over 3. Positive 4 over 3 to be exact. And that's our standard equation. Next, word problems. A Ferris wheel is elevated 1 meter above the ground. When a car reaches the highest point on the Ferris wheel, its altitude from the ground level is 31 meters. How far away from the center horizontally is the car when it is at an altitude of 25 meters? So we could notice that if we plot all the points, the important points here, we could a triangle is formed. So therefore, we have to use the Pythagorean formula, which is a squared plus b squared equals to c squared. This is usually used to find the hypotenuse of the triangle. So now let's explain the different labels we can see in the image. First, the diameter of the circle. Why is it 30? Why isn't it not? Why isn't it 31 meters? Well, we have to remember that our Ferris wheel is elevated 1 meter above the ground. So the altitude of 31 meters is not just the Ferris wheel. It also includes the 1 meter elevation. Therefore, to find the diameter, we simply have to subtract 1 from 31. So 31 minus 1 equals to 30 meters. Now that we have our diameter, simply divide it by 2 to get our radius. 30 divided by 2 is equal to 15 meters. Next, the points of the diameter are important in this problem so that we could find the center, which is 16. But how did we get 16? So first, the points of the diameter. The first one is 0, 31. So that's around here. 0 because we didn't move away from uh, the center of the x-axis, which is 0. Therefore, the x-coordinate for this point is just 0. And the y-coordinate is 31 because, again, it is elevated at 31 meters. And then for the next point, which is down here, it is 0, 1. It is 1. The y coordinate is 1 because our Ferris wheel is elevated 1 meter above the ground. Now, to get the center, we have to use the midpoint formula. So we simply have to replace the values of x's and our y's to the equation. So x sub 1 plus x sub 2 refers to 0 and 0. Y sub 1 plus y sub 2 refers to 31 and 1. So 0 plus 0 is still 0. Divided by 2, it is still 0. 31 plus 1 is 32. Divided by 2 is 16. So therefore, our center is at 0, 16. Next, what is B? Again, we have to remember that a triangle is formed. So we already have the hypotenuse, which is also the radius. So it's 15 meters. And we have this segment right here. This segment right here can be seen as the base of the triangle, which is 9 meters. But how did we get 9 meters? It is said in the question, how far away from the center horizontally is the car when it is at an altitude of 25 meters? So 25 meters. In order for us to find how far away from the center horizontally, so this segment is the car at an altitude of 25 meters, we first have to find the distance between 25 meters directly up and distance between that and our center, which is 16. So simply just uh subtract uh 16 from 25, which is 9. So next, now that we have our values, we simply replace them, or we put them into the equation. So our B becomes 9 and our C becomes 15. Then we have to rearrange the equation so that we can find A there. So we moved positive 9 squared to the other side. So it becomes negative 9. Then to find A, just A, not A squared, we find the square root of 15 squared minus 9 squared, which brings us to our answer, 12. A is equals to 12 meters. And that's it. That concludes our review. Thank you for listening. Good morning, good afternoon, and good evening. This presentation will cover the lesson 3 of STM 111 Precalculus Parabola. So what is a parabola? A parabola is the set of points in the plane that are equidistant from a fixed point F, called the focus, and a fixed line L, called the directrix. Things to remember. First, parts of the parabola. So going back, we have here the parts of the parabola: the axis of symmetry, focus, vertex, directrix, and the latus rectum. Next, the standard equation of parabola. These equations right here are the standard equations of parabola when the vertex is at the origin, while these are the standard equations of parabola when the vertex is not on the origin. Next, you also have to remember how to convert the general equation of parabola to standard equation. Also, we have to remember that if x is being squared, then the parabola can either go upward or it can open downward. It will open upward when our 4p is positive, and it will go downward when our 4p is negative. On the other hand, if y is being squared, then the parabola can either open to the left or to the right. It will open to the left if our 4p is negative, and then it will open to the right when our 4p is positive. Let's begin with our guided practices. First, find the direction, vertex, focus, directrix, axis of symmetry, and latus rectum of the equation. X plus 10 squared equals to negative 100, parenthesis, y minus 50. So first, let's write this down as our guide. Then, based from the given equation, you can already determine the direction. So since x is being squared and our 4p is negative, therefore our direction is downward. Next, we have to find our p. We can do that by equating negative 4p to negative 100. And then after that, we have to divide negative 4 to both sides of the equation. And then if we compute that, we get p equals to 25. Next, for our vertex, we simply have to look for our h and k. So h is the one that is beside x, and k is the one beside y. So in this equation, our h is -10 and our k is +50. Note that it's not +10. It's -10 because this part right here can be written as x minus -10. So we do this so it will be simpler for us to determine our h and k. And then for our focus, we will have to follow this formula. H comma k minus p, and then just simply put in the values for h, k, and p. So that's -10 comma 50 minus 25 equals to -10 comma 25. And then for our directrix, whatever operation we use to find the focus, we do the opposite for the directrix. So that will be y equals to k plus p, and then we put in the values. So that's 50 plus 25 equals to 75. So y equals to 75 is our directrix. As for our AOS, or our x-axis of symmetry, we simply have to look at the variable being squared. So that's x. And then we just have to follow this formula. X equals to h. So that's x equals to -10. Simple as that. Now we have to find the latus rectum. We can either find the latus rectum through 2p plus 2p or just 4p. We usually use 2p plus 2p if we want to graph the parabola. But if we are only going to find the length or the distance of the latus rectum, we can just use 4p. So again, simply put in the values. 2 times 25 plus 2 times 25, that's 50 plus 50, and then we get 100, and then that's it. Next, y squared equals to -24x. So write this down as our guide, and then we may notice that this equation is in the form wherein the center, the vertex rather, is at the origin. But first, before we do the vertex, let's determine the direction. So since y squared and then our 4p is negative, that means our direction is leftward. And now we have to find p. So simply equate -4p to -24, and then divide -4 to both sides of the equation to get p equals to 6. Now for the vertex. So as I have mentioned, this equation is an equation wherein the vertex is not, I mean, the vertex is at the origin. So that means the coordinates will be 0 and 0. After that, you can get the focus. So since x is the variable that is not being squared, that's the variable that we will be manipulating to find the focus and our directrix. So we simply have to follow this formula, h minus p comma k. So simply put in the values, 0 minus 6, 6, comma, 0, 0. So that will give us negative 6, comma, 0. For our directrix, again, do the opposite operation. So that will give us x equals h plus p. So 0 plus 6, that's x equals to 6. For our AOS, we look at the variable being squared, which is y. So y equals k, which is basically 0. So y equals to 0. That's our answer. For our lattice rectum, again, simply put in the values for p. 2 times 6 plus 2 times 6, 12 plus 12 is 24. Or you can just do 4p. So 4 times 6 is 24. Next, y plus 30 squared equals to 32. Parenthesis x plus 5. So let's write this down as our guide. And then let's determine the direction. So y is being squared and our 4p is positive. So that can only mean the direction goes rightward. The parabola opens to the right. Now, let's find our p. So let's equate 4p equals to 32. So earlier we used negative 4p, but now we used positive 4p. Why is that? Well, we simply have to follow the given 4p, which is positive 32. So since it's positive 32, we also use positive 4p to equate when we equate it. So again, 4p equals to 32, and then we divide the equation by 4 to get p equals to 8. Next, to find our vertex, simply look for the h and k. So that's for our h, that's negative 5. And then for our k, that's negative 30. After that, we can now get our focus. So simply follow the formula, h plus p, comma k, and then put in the value for h, for p, and for k. So that's negative 5 plus 8, comma, negative 30. And then if you compute that, that will give us 3, comma, negative 30 as our focus. For our directrix, we do the opposite. So that's x equals to h minus p. So put in the values, negative 5 minus 8, which will give us x equals to negative 13. For our AOS, that's y equals to k, which is basically negative 30. And then for our lattice rectum, let's put in the value for p, that's 8, and then we compute to get 32. Next, x plus 12 squared equals to 16, parenthesis y plus 7. Again, write this down as our guide, and then let's determine the direction. So since x is being squared and the 4p is positive, then the direction is upward. And then now, let's find p. So do that by equating 4p to 16 and then dividing 4 to both sides of the equation. So that's 16 over 4, which will give us 4. Now for our vertex, simply look at our h and k. So that's -12 and -7. For our focus, now since y is not being squared, then that's the variable that we will be manipulating for our focus and um, directrix. So we'll follow this h comma k plus p. So by the way, for our previous examples, it was k minus p, or it was h minus p. Right now, it's k plus p because we will follow the given for p. So since it is positive, then we will also, the p here will also be positive. That means we will add p. But for example, if it was -16, then we will subtract p. So k minus p. But for this equation, it's positive, so we'll follow this. So put in the values. So that's -12 comma -7 plus 4, which will give us -12 comma -3. For our directrix, we do the opposite. Y equals k minus p. So put in the values. -7 minus 4, which will give us -11. For our AOS, let's look at our x, which has the value of -12 because x equals to h. Then lastly, for our latus rectum, we put in the value of p, which is 4, and then we compute, and then we get 16. Now, let us convert the general equation to standard form, or the standard equation. X squared minus 6x minus y plus 9. So first, we have to move y, negative y plus 9, so that we will separate the x's and the y. So from negative y, it became positive y because every time we move something to the other side, the sign changes. So positive 9 became negative 9. And then now we are going to complete the square. So we get the value of b, which is -6x, and then we divide. I'm oh wait, no, the value of b is just -6. And then we divide that by 2 to get -3, and then we square that to get 9. After that, we add 9 to both sides of the equation. So whatever we add here, we also add to the other side. So if we calculate that, we compute that, we get x minus 3 squared equals to y. So -9 plus 9, that's 0. And then we simplify this to get x minus 3. So a trick here is to look at our answer when we divide b by 2. So -6 divided by 2, that's -3. So that's why we put -3 here, or -3 here. Next, convert -x squared plus 6x plus y minus 4 equals to 0. So for this equation, it's easier if we move the x's to the other side to make our leading coefficient positive rather than negative. So from there, we complete the square. Get the value of b, which is -6. Divide that by 2. That gives us -3, and then we square that to give us 9. So we add 9 to both sides of the equation. And then if we compute this, we get y plus 5 equals to x minus 3, and then squared. Simple as that. Next, negative y squared plus 8y plus x plus 12 equals to 0. So again, we move the y's to the other side to make it positive, to make the y squared positive. And then we complete the square. We get the value of b, which is negative 8. We divide that by 2, we get -4. And then we square that to get 16. So we add 16 to both sides. So we add whatever we add here, we also add here. So that will give us x plus 28 equals to y minus 4 squared. So for this one, again, let's regroup. Let's isolate the x and then the y's. So we get x plus 10 equals to y squared plus 4y. We complete the square. So let's get the value of b, which is positive 4. Divide that by 2. And then we square that to get 4. And now we completed the square. So we added plus 4. So whatever we add here, we also add here. So if you compute that, we get x plus 14 equals to y plus 2 squared. Now for our word problems, a searchlight has a parabolic reflector that forms a bowl which is 12 inches wide from rim to rim and 8 inches deep as shown in the figure in the right. If the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? So when dealing with word problems, it's easier if we put the vertex and to at the origin, unless if it's specified. So right here it is not specified, so we'll just put our vertex at the origin. So here we got our vertex right here at 0, 0. So that's why we have this equation. This is the one that we will be using. Next, in order to find our um, the focus, we have to find our P. So we can do that by looking for a point in the parabola. So our point will be 6, comma 8. But how did we get that? So remember that from here to here, that's 12. And then from here to here, that's 8. So that means the y value for this point will be 8. And then this, the x coordinate or the x value for this point will be 6. Why? Because again, this part here is 0. So basically, this line cuts the width of the bow into half. So 12 divided by 2 is 6. So we could count 0, 1, 2, 3, 4, 5, and 6. And then on the other side, if for example we wanted to use this point, let's imagine that there's another point here. So the coordinates for that will be -6, comma 8. Kasi um, 0, -1, -2, -3, -4, -5, and -6. So that's how we came up with the point 6, 8. After that, let's put in these values to our equation. So for our x, that's 6. Then for our y, that's 8. So we compute that to get 36 equals to 32p. And to get p, we have to isolate it. So we get 36 divided by 32. So our answer is 9/8, or basically 1.125. So that's how far the filament of the light bulb should be from the vertex. So this. Next, a bridge shaped like a parabolic arc has a horizontal distance of 20 feet. The center and highest point of the arc is 5 feet above the ground. What is the height of the bridge at a point 5 feet from the center? So we have here our representation of the problem. So the width of this parabola, or the arc, is 20. So we start at, again, remember, to make things easier, we have to put our uh, vertex at the origin. But for this equation, it is specified that our vertex is 5 feet above the ground. So still our x will be 0, but for our y, it will be 5, because it says here 5 feet above the ground. So next, the horizontal distance is 20 feet. So we start from -10, and then we end at 10. And then this green dot right here is um, the point that we are looking for. So this point right here is 5 feet. So 5 feet. So horizontally, it is 5 feet, but we are looking for its height. Its height. So we start by finding the equation that we are going to use. So we'll write this down as our guide, and then we put in the values for um, the vertex. So again, our vertex is 0, 5. So therefore, we write 0 and 5. For that, we simplify that to get x squared equals to -4p parenthesis y minus 5. It is -4p so that the parabola opens downward. That creates an arc. Now, let us solve for p. We can use the point 10, 0 to get that. So we simply have to put in the values for x and y. So for our x, that is 10, and then for our y, that is 0. Let's look at our graph again. We will be using this point. So it's 10, 0. After that, we compute. So 10 squared, that's 100. -4 times -5, because 0 minus 5 is just -5. So we multiply that to -4 to get positive 20p. So after that, we divide 100 by 20 to isolate P. Then we get P equals to 5. Now we have our P. So we will simplify this to get x squared equals to negative 20 parenthesis y minus 5. Now, let's write this down again to get our to as our guide. And then it says here that what is the height of the bridge at a point 5 feet from the center? So again, this green point, the height of this point is 5 feet from the center. So we look at the x-axis. So that's 1, 2, 3, 4, 5. So that's our x. Remember that that's our x. And then the y or the height is still missing. So that's what we are trying to find. So since it is 5, our x is 5, we put in the value for that. So that's 5 squared equals to negative 20 parenthesis y minus 5. So that becomes 25. And then we divide the equation by negative 20 to get 25 over negative 20. And then um, we're left with y minus 5. Next, we move the 5. So negative 5 becomes positive 5. And if we compute that, we get y equals to 3.75. That is our height. And that's it. That concludes our review. Thank you for listening. Good morning, good afternoon, good evening. This presentation will cover Lesson 4 of STM 111 Precalculus Ellipse. What is an ellipse? An ellipse is the set of all points in a plane such that the sum of the distances from the fixed points called the foci is constant. Things to remember. So firstly, our A is the distance from the center to a vertex. So letter A. So our A is from here, the center, to a vertex. So that means from here and to here is also our A, because this point is also our vertex. Next, B is the distance from the center to the co-vertex. So this is B, and this is also B. Then for our C, it is the measurement or the distance from the center to a focus. So from here to here, that's our C. Next, we have to remember when an ellipse is horizontal or vertical. To be precise, when the major axis is horizontal or vertical. So our ellipse or major axis is horizontal when our a squared is with our x. So next, it is vertical when our a squared is with our y. So we have to remember all of this in order for us to find the different properties or parts of the ellipse. Next, We also have to remember how to convert general form to standard form. Let's begin with our guided practices. First, find the major and minor axis and the coordinates of the center, vertices, foci, and co-vertices of x squared over 16 plus y squared over 4 equals to 1. So from there, we can already determine our center. Since it is only x squared and it is only y squared, therefore, our center is at the origin, or 0, 0. Next, we have to find the orientation of our major axis. So for this equation, it is horizontal. Why? Because our A, so by the way, A is the number which is greater between the two. So in this equation, which is greater, 16 or 4? So of course, that's 16. Therefore, 16 is A. And since it is our A squared is with X, therefore our major axis is horizontal. Next, we have to find A, B, and C. So for our A, we already know that our A squared is 16. So we simply have to find the square root of 16, which is 4. Next, for our B, we do the same. We square the value of the value of B squared rather, which is 4. So the square root of 4 is 2. And then for our C, we follow this formula. C equals to the square root of A squared minus B squared. So we simply have to put in the values. So that's 16 minus 4. So that's 12. And then we find the square root of 12 and we have 3.46. So if you try to plot the ellipse, we'll get something like this. Now we get the values that we determined earlier, and then we can now start to complete the table. So first, for our major axis, it's simply 2a, and for our minor axis, it's simply 2b. As for our vertices, it's h plus and minus a comma k. So here we will manipulate for our vertices, we will manipulate h. Why? Because again, our a our a squared is with our h or our x. Then for our co-vertices, we will manipulate k or the y coordinate, because our b is with y. So for vertices, by the way, the number that we will be using is a, and for our co-vertices, we will be using b, and for our foci, it's c. So in the foci, we simply have to follow the vertices. So since again our a squared rather is with our x, therefore that's the variable that we will be manipulating. So for our foci, that's h plus and minus c comma k. So earlier we already determined the orientation of the major axis, which is horizontal. So now we simply have to compute for 2a. So 2 times the value of a, which is 4, so that gives us 8. And then for our minor axis, whatever the orientation of the major axis, the orientation of the minor axis is the opposite. So from horizontal, it is vertical. So we compute 2b. So that's 2 times 2, which is 4. So 8 and 4 are the measurements of the major and minor axis respectively. Next, for our vertices, so that's h plus and minus a, comma k. So for our vertex number 1, our first vertex, so we'll use first the plus or the addition. So h plus a. So our h is 0, and then we add 0 to, or rather we add a to 0. So that's 0 plus 4, which is basically 4. And then we just simply copy our k, which is also 0. For our second vertex, it's h minus a. So again, 0 minus 4, that's negative 4, and then we simply copy our k. Now for our co-vertices, we will manipulate k, and we will use b. So that's h comma k plus b. So k is 0 plus b, so that's 2. So 0 plus 2, that gives us positive 2. So our co-vertex number 1 or sub 1 is 0 comma 2. Next, h comma k minus b. So 0 minus 2, that's 0 comma negative 2. Now for our foci, it's h plus c. So h plus c, 0 plus 3.46. So that gives us 3.46 comma 0. So we just copied again the k, which is 0. Next, it's h minus c comma k. So 0 minus 3.46, that gives us negative 3.46 comma 0. And then that's it. Now, next, we have to find the major and minor axis and the coordinates of the center, vertices, foci, and co-vertices of x squared over 9 plus y squared over 36 equals to 1. So from the given, we can already determine the center, which is again, since it's only x squared and y squared, then our center is 0, 0. Now for the orientation of our major axis, it's vertical. Why? Because now we have to determine which one is A. So A again is always the bigger number. So between 9 and 36, of course, 36 is the bigger number. And since since 36 is our A squared, and A squared is with Y, that means our major axis is vertical. So we find our A, B, and C. So since we already know that A squared is 36, we simply have to find its square root, which is 16. We do the same with B squared, which is 9. So our square root of 9 is 3. Then we follow, for our C, we follow this formula. So the square root of A squared minus B squared. So that gives us 5.196. If we try to plot it, it gives us this ellipse. So now we get the values again, and then we complete our table. So for our major axis, it's just 2A, minor axis, 2B, and then we simply have to follow this. So now, since our A is with Y, so our A squared is with Y, we will manipulate, for our vertices, we will manipulate K using A. And then for our co-vertices, we will manipulate H using B. And for our foci, we will again manipulate K using C. So we'll have this. So our major axis, it's vertical. So 2a, so that's 2 times 6, which is 12. For our minor axis, it's horizontal. That's 2b, so 2 times 3, that's 6. For our vertices, that's h comma k plus a. So k is 0 plus a, which is 6. So that's basically positive 6. So our vertex number 1, or v sub 1, is 0 comma positive 6. And then h comma k minus a. So k is 0, a is 6, so 0 minus 6, that's 0 comma negative 6. For our co-vertices, we have h plus b, so 0 plus 3 gives us positive 3, and then we just copy the k. So our co our w sub 1 is 3 comma 0. So again, h minus b comma k. So our h again is 0 minus b, that's 3. So that gives us negative 3. So the coordinates for our w sub 2 will be negative 3 comma 0. For our foci, it's h comma k plus c. So 0 plus 5.196. That gives us positive 5.196. So our coordinates will be 0 comma 5.196. And then we do the subtraction. So h comma k minus c. So that gives us 0 comma negative 5.196. So we just simply have to put in the values. So it's that simple. Next, x minus 5 squared over 49 plus y minus 4 squared over 25 equals to 1. So again, we look at the given equation to find the center, and that's at 5 comma 4. So we could see beside x our h, and beside y our k. So that's positive 5 and positive 4. So disregarding the negative sign. Next, we find our major axis. The orientation of our major axis, which is horizontal. Since 49 is bigger than 25, that means it's our a squared, and our a squared is with x. So therefore, it's horizontal. Now let's find our a, b, and c. So the square root of 49 is 7. The square root of 25 is 5. And the square root of 49 minus 25 is 4.90, or just simply 4.9. So if you try to plot it, it will come up like this. So now let's complete the table. So for our major axis, it is horizontal. And so 2a, so that's 2 times 7, which is 14. For our minor axis, it's vertical. And 2b is basically 2 times 5, because b is equal to 5. So that's 10. For our vertices, we manipulate h using a. So that's h plus a comma k. H is 5 again, remember. H is 5 plus 7, because a is equal to 7. So 5 plus 7 That gives us positive 12. And then we simply copy the k. Our k is 4. So our first vertex is 12 comma 4. Next, we subtract. So h minus a comma k. So again, h is 5 minus 7. That gives us negative 2. And then we just copy the k. So that's negative 2 comma 4. For our covertices, it is h comma k plus b. So k plus b is 4 plus 5. So that gives us 9. So we just copy h. H again is 5. And then 4 plus 5, that's 9. So we have 9. So 5 comma 9. Next, h comma k minus b. So again, we copy h, which is 5. And then we do the computation. So k, 4 minus b, which is 5. So 4 minus 5, that's negative 1. So we have our coordinates here, 5 comma negative 1. For our foci, it's h plus c comma k. H again is 5 plus c, which is 4.9. That gives us 9.9. And then we just copy k. So 9.9 comma 4. And then next, h minus c comma k. So that's 5 minus 4.9. That gives us 0.1 and then comma 4. Now let's convert 16x squared plus 4y squared minus 32x minus 16y minus 32 equals to 0 to standard form. So firstly, we have to move our or isolate our constants. So our constant for this equation is negative 32. So if you move that to the other side, it becomes positive 32. Now we rearrange or we group the variables. So we group the x's and the y's. So that becomes 16x squared minus 32x plus 4y squared minus 16y equals to 32. So then we will have to factor out whatever number is beside x squared and y squared. So for our x's, we factor out 16. So 16 divided by 16, that's 1. And 16, I mean negative 32 divided by 16 is negative 2. So we simply took 16 out of the equation, or this part of the equation. Then for our 4y squared minus 16y, we factor out 4. So our 4y squared becomes just y squared, and our negative 16y becomes negative 4y equals to 32. So that's how you factor out. That's how you factor out. So now, since we have um, this, we have x squared minus 2x and y squared minus 4y, we can now complete the square. So we can change it into a perfect square trinomial. So again, to do that, we simply have to do b over 2 squared. So negative 2 divided by 2, that's negative 1. So negative 1 squared is just positive 1. So we add 1 here. And then for negative 4y, we just divide negative 4 by 2. That's negative 2. And then we square negative 2. So negative 2 squared is just 4. So we add 4 here. Now, why did we add 16 and 16 to the other side? Why didn't we add 1, 1, and 4? So we have to remember that before we add numbers to the other side, we have to distribute our the 16 and 4 first to whatever number that we came up earlier. So that 16 times 1, so which is still 16. So that's what we are going to add. And then 4 times 4, that is also 16. So we'll add 16. So we'll simplify this equation to get 16, parenthesis, x minus 1, parenthesis squared, plus 4, parenthesis y minus 2, parenthesis squared, equals to 64. Now, when we reach this part of the process of converting general form to standard form, we then divide the whole equation by whatever uh, our constant number is. So for this, it's 64. So we divide the whole equation by 64. So 16 divided by 64, that's 1/4. So that's why under x minus 1 squared, there's a 4. So 1, we did not include the 1 because we don't do that. We just simply uh, make it disappear, but it's still there. There's still 1 here, so it's 1/4. Again, 16 over 64 is just 1/4. Next, 4 over 64 is just 1 over 16. So 64 divided by 64, that's 1. And then we'll have this answer. So parenthesis x minus 1, parenthesis squared over 4, plus parenthesis y minus 2, parenthesis squared over 16, equals to 1. Mhm. So just to recap, first, we have to move our constants to the other side. So from negative 32, we moved it to the other side, becomes positive 2. And then we have to regroup or rearrange the terms. So we group the x's and the y's. So after that, we factor out the coefficients of x squared and y squared. Then once we reach this point, we complete the square, and then we simplify to get this. And then after, when you reach this point, we divide the whole equation by the constant, which is 64. So when we divide that, we get our answer. Next, suppose that the orbit of a planet is in the shape of an ellipse, for which the distance between the vertices is 1,400 million kilometers, and the distance between the foci is 800 million kilometers. Find an equation of the orbit. So let us plot first our points. So by the way, um, for simplicity, we will only use 1,400. We will not include, for the meantime, we will not include the million. So that's also true for 800. We will only use 800, not 800 million. But still, there are, again, million. So it's still 1,400 million and 800 million. So first, let's write down this equation as our guide. So x squared over a squared plus y squared over b squared. So we always put our center at the origin when we're dealing with word problems to make things easier. So from there, we find our a. So how do we determine that? So going back to the question or the situation, it is said that the vertices, the distance between the vertices is 1,400. So we divide that by 2 to get 700, because remember that the measurement of the line segment V1, so starting from here and ending at V2 or V sub 2 is just 2a. So that means from the center to one vertex is just a. So we simply divide 1,400 by 2. So V1 to V2, that's 1,400. But V1 to just the center, that is just 700. So our A is 700. Now, we move on to C, which is 400. So again, similar thing. So from F1 to F2, that's 800. We divide that by 2 to get 400. So our B is missing. So how do we find it? Because we need B to get the equation of the orbit. So to find B, it is simply B is equal to the square root of 700 squared minus 400 squared. So again, our A squared is 700 and our C is 400. So if you compute that, we get 574.46. So going back to our guide, x squared over a squared plus y squared over b squared equals to 1, we can just put in the values that we determined. So for our a, that's 700 squared. And then for our b, since we found it, so 574.46 squared. So that's our equation for the orbit. Now, the arc of a bridge is in the shape of a semi-ellipse or semi-ellipse with its major axis at the water level. Suppose that the arc is 22 feet high in the middle and 100 feet across its major axis. How high above the water level is the arc at a point of 30 feet from the center horizontally? So um, our bridge, our ellipse, or our semi-ellipse is 100 feet across. So that means our A is just 50, while our co-vertex or co-vertex is just 22 feet, because it is said that suppose the arc is 22 feet high in the middle. So our middle is at the center. So now, how high above the water level is the arc at a point of 30 feet from the center? So 30 feet from the center. So from 0.0, 0. So to do that, to find that, we first have to write down x squared over a squared plus y squared over b squared equals to 1 as our guide. And then since we have the given value of x, a, and b, we can easily get our y, which is the height, because y again is um, the variable for height. So how did we say that x is 30? So from the question, how high above the water level is the arc? At a point of 30 feet from the center horizontally. So that means we moved from the center 30 feet on the x-axis. So remember, x-axis. So therefore, 30 is um, our x coordinate. So we simply put in 30. And then for our a, like I have said earlier, since the bridge is 100 feet across, so that's 2a. So that's what from one vertex to another. So we divide that to get by 2. We divide that by 2 to get our a. So 100 divided by 2, that's simply 50. So plus y squared over 22 squared. So 22 is our b, because that's uh, from the center to a co-vertex. So from there, we isolate our y. So we move 30 squared over 50 squared to the other side. So from being positive, it becomes negative. So that's 1 minus 30 squared over 50 squared. And then again, we try to isolate y squared. So we multiply 22 squared to both sides of the equation. So if we will multiply 22 squared to this part of the equation, they will cancel out, which will just give us y squared. So on the other side, it becomes 22 squared times 1 minus 32 squared. 30 squared minus over 30 squared over 50 squared. So let's calculate this part. So that's 309.76. And then we find its square root, which will give us 17.6. So at a point 30 feet from the center horizontally, the arc is 17.6 feet high above the water level. That's it. I hope you listened and you learned well. So thank you for listening. Good morning, good afternoon, good evening. This presentation will cover Lesson 5 of STM 111, Precalculus, Hyperbola. What is a hyperbola? A hyperbola is a set of all points in a plane such that the absolute difference from the distances from the fixed points, called the foci, is constant. Things to remember. So A is the measurement of from the center to a vertex. So from the center to a vertex. So this is A, and this is also A. B is the measurement from the center to a co-vertex. So B is from the center to a co-vertex. So this is B, and this is also B. As for our C, it is the measurement from center to focus. So from center to all the way here to a focus. So from the center to a focus. On the other side, that's also C. So center to focus. Next, we have to remember when our transverse axis, or you can just call it the major axis if you want, is horizontal or vertical. So it is horizontal when x squared comes first before y squared. So since for this equation, x squared comes first, therefore our transverse axis is horizontal. So when it is horizontal, the curves open to the left and to the right. So this will be needed, all of this, to find the properties of a hyperbola. Next, the transverse axis is vertical when y squared comes first. So that's it. Next, so going back, we may notice that for our asymptotes, it for when the transverse axis is horizontal, or when x comes first, our to find our asymptotes, it is only y equals to plus and minus b over a squared. But when y squared comes first, to find our asymptotes, it is y equals plus minus a over b x. So when our center is not on the origin, so unlike earlier, these two, to find our asymptotes, we use this equation right here. So that's y minus k equals to plus minus b over a if x comes first, parenthesis x minus h. And then when y comes first, it's y minus k equals to plus minus a over b, parenthesis x minus h. So the only thing that changed was the b over a and a over b. Next, let's remember how to convert general form to standard form. So let's begin with our guided practices. Find the major and minor axis and the coordinates of the center, vertices, foci, covertices, and asymptotes of y squared over 16 minus x squared over 4 equals to 1. So from the equation, the given equation, we can determine the center. The center is at the origin because it's just y squared and it's just x squared. So that's 0, 0. Now, our major axis or our transverse axis is vertical. Why is that? Again, because y came first before x. So that means it is vertical. Next, we have to find our a, b, and our c. So for our a, we simply find the square root of 16, and that's 4. For our b, we do the same. We find the square root of 4, which is 2. And then for c, we simply have to follow this formula. So to find c, that's the square root of a squared plus b squared. So the square root of 16 plus 4 is 4.47. So from there, let's complete the table. So for our major axis, that's 2a, minor axis, that's 2b, vertices, that's h, comma, k plus a. K plus a. So again, we manipulate k because y squared came first. So for our covertices, we do the opposites. We manipulate h using b. So h plus minus b, comma, k. For our foci, we use again the k. I mean, we manipulate again the k. So that's h, comma, k plus minus c. For our asymptotes, since the center is at the origin, you can just use this. So that's y equals plus minus a over b, because again, y came first. Y squared came first. So that's a over b squared. So for our major axis, that's vertical, 2a. So that's 2 times 4, that's 8. Minor axis, so whatever um, our answer for our major axis is, that's the opposite for the minor. So for our major, that's vertical. So for our minor, that's horizontal. So 2b, so that's 2 times 2, that's 4. For our vertices, h comma k plus a. So k is 0 plus a, that's 4, so that's positive 4. So the coordinates for v sub 1 will be 0 comma 4. So we just copy h. H is still 0. So next, h comma k minus a. So that's 0 minus 4, which gives us negative 4. So 0 comma negative 4. For our covertices, it's h plus b. So 0 plus 2 comma k. So that's 2 comma 0. Next, h minus b comma k. So 0 minus 2 comma 0. So that's basically negative 2 comma 0. For our foci, it's h minus k plus c. K again is still 0 plus c 4.47. So that's positive 4.47. So the coordinates for f sub 1 will be 0 comma 4.47. Next, h comma k minus c. So that's 0 minus 4.47. That gives us with the coordinates of 0 comma negative 4.47. For our asymptotes, we just simply put in the values. So y equals to plus and minus a. So that's 4 over b. So that's 2. So 4 over 2 is just 2x. So y is equal to plus and minus 2x. So if we will try to graph this equation, it will look something like this. Next, parenthesis x plus 2 parenthesis squared over 4 minus y plus 5 squared over 12 equals to 1. So we begin with the center, which is negative 2. Our h is negative 2 and our k is negative 5. Then we proceed with the orientation of our major axis or our transverse axis, which is horizontal, again because x came first. So we find our a, b, and c. So for our a and b, they don't change position. So the first denominator is always a and the second denominator is always b. So we simply have to find the square root of 4, that's 2, and the square root of 12, which is, we can just write it as the square root of 12. For our um, c, we simply have to follow this. So that's c is equal to the square root of a squared plus b squared. So that's 4 plus 12, that's 16. So the square root of 16 is 4. Then we complete the table. So for our major axis, again, it's horizontal. So 2a is 2 times 2, that's 4. Minor axis, vertical, that's 2b, so 2 times the square root of 12. So that's 4, the square root of 3. You can just use the calculator to get this. So next, the vertices. Since x came first, we manipulate h using a. So h plus a. So our h again is -2 plus a, which is 2. So -2 plus 2 is 0, comma k. So we just copy k. So that's -5. So 0, 0, comma -5. Then h minus a, comma k. So h minus a, that's -2 minus 2, which gives us -4, comma -5. For our co-vertices, it's h, comma k plus b. So h is -2, so we just copy that. And for our k, it's -5, so plus b, which is the square root of 12. We can just simply leave it at that. So for our first co-vertex, that's -2, comma k plus the square root of 12, or k plus b, which so b is square root of 12 and k is -5. So next, for the next co-vertex, that's h, comma k minus b. So we can just put in the value. You can just leave it at that because we have a square root right here. So next, for our foci, it's h plus c, comma k. So h is again -2. For our c, that's 4. So -2 plus 4 is +2. So, and then comma k. So comma -5. Next, h minus c. So h is -2 minus 4. So that's -6, comma -5. For our asymptotes, that's since the equation is not the center of the equation, or the hyperbola is not at the origin, we use this equation right here. So that's y minus k equals to plus and minus b over a, because remember, the x came first. B over a parenthesis x minus h. So that's y plus 5 equals to plus and minus. So b over a, that's square root of 12 over a. So square root of 12 over 2, which will give us square root of 3. So parenthesis x plus 2. If we try to graph it, it will come out like this. Next, y plus 2 squared over 16 minus x minus 3 squared over 9 equals to 1. So we determine the center, which is 3, comma, -2. So again, we have to look for the h. So that's always beside x. So that's 3. And then for our k, that's -2. Next, the orientation of our major axis, which is vertical, because y came first. So next, we have to find our a, b, and c. For our a, we simply find the square root of 16, which is 4. For our b, we find the square root of 9, which is 3. And then we follow this formula to get 5. So the square root of a squared plus b squared, so that's 16 plus 9, 25. So the square root of 25 is 5. Then we complete the table. So again, our major axis is vertical. So 2a is 2 times 4, so that's 8. And then our minor axis is horizontal. So that's 2b. So 2 times 3, which is 6. For our vertices, since y came first, we will manipulate k using a. So h, comma, k plus a. So again, our k is negative 2 plus a, so that's 4. Negative 2 plus 4, that is 2. So for our h, we just copy it, which is 3. So 3, comma, 2. Next, h, comma, k minus a. So k is negative 2 minus 4. That gives us negative 6. So 3, comma, negative 6. For our co-vertices, it's h plus b, comma, k. So h plus b, that's 3 plus 3, which is 6. So 6, comma, negative 2. The next, h minus b, comma, k. So h minus b, so that's 3 minus 3, that's 0. So the coordinates for our the second covertex is 0, comma, negative 2. So just copy the k, which is negative 2. Next, for our foci, it's h, comma, k plus c. So k plus c, that's negative 2 plus 5. So that gives us 3. So we just copy the h, which is 3, comma, and then 3. Next, h, comma, k minus c. So k is negative 2 minus 5. That gives us negative 7. So our answer would be 3, comma, negative 7. For our asymptotes, we follow this. Y minus k equals to plus and positive and negative a over b, because it's a over b because y came first. So a over b parenthesis x minus h. So we simply put in the values. So y plus 2 equals to plus and minus, or positive and negative, 4 over 3. So a over b, so a is 4, b is 3. So 4 over 3 parenthesis x minus 3. So this will be its graph. Next, convert 3x squared minus y squared plus 18x plus 4y plus 35 equals to 0 to standard form. So first, we have to isolate the constants. So our constant here is positive 35. If we move that to the other side, it becomes negative 35. Next, we rearrange. We group together the x's and the y's. And then there. So here, from being negative y squared plus 4y, it became positive y squared minus 4y because we factor out the negative sign. So when the y squared, or the variable right here, is negative, we have to make it positive. So to do that, we have to factor out the negative sign. So it also affects the succeeding term, which is 4y. So after doing that, we then factor out the coefficients beside the coefficient beside I mean x. So since that is 3, factor out 3. So 3 divided by 3, that's 1. 18 divided by 3, that's 6. So for this one, we don't need to do it anymore because we already did. We factored out the negative sign, so which is also negative 1. So once we reach this point, we then complete the square. So we do that by getting b over 2 and then squaring that answer. So our b here is 6. So 6 over 2, that's 3 squared equals to 9. And then for this part here, it's negative 4 over 2 equals to negative 2. squared, which is 4. So let's add 9 here and add 4 here. So now, why didn't we add 9 here or 4 here? Why did we add 27 and -4? So again, we have to remember that we have to distribute first uh, the number that we factored out earlier. So for this, that's 3 times 9 is positive 27. And then -1 times positive 4, that's -4. So if we compute this, we simplify that, we reach this answer. So when we're at this point now, we simply have to divide the equation by the constant, which is -12. So we divide -12 with -12. We divide 3 parenthesis x plus 3 parenthesis squared by -12 and so on. So if we do that, we get this answer. So 3 divided by -12 is just -1/4. So -1 divided by -12 is just 1/12. So -12 over -12 is obviously 1, positive 1. So our answer can either be this, or if you want, we can do this. Next, 4x squared minus 25y squared minus 24x equals to 64. So this equation is pretty simple. So we simply have to regroup or rearrange the terms since the constant number is already isolated. So we put a parenthesis to help us visualize the separation, and it will help us later on when we complete the square. So before completing the square, we will again factor out the coefficient of x squared. So that's, which is 4. So 4 divided by 4, that's 1. -24 divided by 4 is -6. So then we can now complete the square. So -6 divided by 2, that's -3 squared, that is 9. Oh, by the way, we didn't complete the square for 25y squared because there is no need for that, since it's just 25y squared. There's no other y's in the equation. So after that, we add here plus 9, and we add here plus 36 because 4 times 9, that's 36. So we compute that, we simplify to get this. So from perfect square trinomial, we make it as square of binomial. So when we reach this point, we divide the equation by the constant, which is 100. So divide that by 100, we get uh, this equation. So 4 over 100, that's 1 over 25, and -1 over, -25 over 100 is just -1/4 equals to 1. So this is our answer. Now for our problem solving, the model of a hyperbolic tower that is 160 meters high is modeled by x squared over 16 minus y squared over 225 equals to 1. Find the width of the tower at the narrowest point in the middle and at the top of the tower. So first, let's draw or represent the hyperbolic tower. So it will look something like this. So we are looking for the measurement of this part here, the narrowest point in the middle, and the top of the tower. So that, okay, so this and this. So the narrowest point in the middle and at the top, the narrowest point in the middle is basically our transverse axis. So that means the center can be found around here in the middle here. So that means this point here and here are the vertices. So by the way, we have to label the height. So that's, so from the top to the bottom, that's 160, 160 meters. So to find the measurement of the width at the narrowest point in the middle, we first have to find the center, the A and the B. So to do that, we assume that when dealing with word problems, it's always best to put the center at the origin to make uh, it easier for us, unless it is specified. So our center is equal to or is at 0 comma 0. Now, as for our A, we can already determine that just by looking at the equation. So our A always comes first and then our B. So for our A, that's 6. For our A squared, that's 16. So our A, that's just basically 4 because square root of 16 is just 4. Then for our B, the square root of 225 is 15. And then now we can get the width at the narrowest point in the middle, because remember that the line segment from one vertex to the other vertex is just 2a. So let's write v sub 1, line segment v sub 1, and v sub 2 is just 2a. So since we already know that a is 4, so we simply put in the values. So that's 4, so equals to 8. So the width at the narrowest point in the middle measures 8 meters. So that's it. We're almost done. So next, we have to find the width at the top of the tower. How do we do that? So first, let's determine a point in the parabola. So uh, here, let's find a point here. So how do we know the coordinates of this point? So it is said that the tower measures 160 meters high. So if at the middle, so let's put an imaginary line here. This will be our transverse line or axis. So this cuts the tower in halves. So from 160, it becomes 80. So from here to the top, that's 80, and from here to down, that's also 80. So that means this point right here is x comma 80. So we will use this to find the width at the top. So to do that, we simply have to put in the values that we have to the model, which is x squared over 16 minus, so for our y coordinate, so that's 80. 80 squared over 225. So again, it's not 160, it's 80 because we put the transverse line or axis in the middle, which cuts the tower into halves. So that's 80. Now, wait, let's equate that to 1. There. After that, to find x, we simply have to isolate it. So from there, so x squared over 16 minus, I mean equals to 1. So from negative 80 squared over 225, it becomes positive. So plus 80 squared over 25 there. So next, again, we have to isolate x. So we multiply 16 to both sides. So if we multiply 16 to x squared over 16, it will cancel out. So it will only give us x squared equals to, so again, we multiply 16 to both sides. So that will give us 16 parenthesis 1 plus 80 squared over 225 there. So if we calculate that, that will give us 16 parenthesis 1 plus 80 squared over 225. That is 4 4 7 1 471 over 1 9. So wait, let's equate x squared to that. Now the next step is to square this. You have to square this. So to find x, square that. So square root of, we have to find the square root rather. We have to find the square root of 471 and 1/9. So that gives us 4 square root of 2 6 5 over 3. So this is our x. That is not yet our answer because the measurement of from this point to this point, since our conjugate axis cuts it in halves. So we have to multiply x by 2 because we only x only represents the measurement from this point to this point. So to find the width, we multiply it by 2. So 2x, that's 2x. So 2 times 4 square root of 2, 6, 5 over 3 is, it is around or roughly 43.41. So this and yeah, so this is our answer. Also, so first let's compile our answer to make it easier. So from the line segment v sub 1, v sub 2, that is 8 meters. 8 meters. So this refers to this, the width of this at the narrowest point in the middle. Then at the top of the tower, that is 2x. So it's equal to 43, roughly point 2. Right. So it is roughly 43.41. So that's our answer. I hope you learned and listened well. So thank you for listening, and goodbye.